Okay, so what we'll do today, we'll complete the topics about subcontracting. It's actually quite a tricky topic because there's really a logical foundation behind. That's why I tried to give you a little bit warm-up last time. I'll review that quickly, but today we're going to do quite a bit of math today, a little bit, not too much, right? But the rules that we're going to talk about, you don't memorize them, but you got to understand them because we might give a different shape of problems in the exam. Okay? Subcontracting is a very popular topic for the exam, I can tell you. Okay? But if you got confusion, let me know. Especially I'll point to you where exactly students usually get confused. We haven't got there yet, but we will. Very quickly. So we talk about, basically we're still talking about the context of inheritance, especially we put contracts into the play. Okay, that's going to be a little bit tricky. Especially if you got a precondition and postcondition in the parents, what does it really mean when you have a subclass? Also, if you leave out the require and ensure for the parents, what does it really mean for the child class? Do they have any constraint? Another scenario, what if you have a child class that does not have any pre or post condition? What does it really mean to do with the contract in the parent class, right? We got different scenarios that we're going to consider. Okay, so last time we talked about when we are given two preconditions, P1 and P2, we say P2 require less than P1. What that means exactly, right? Require less intuitively simply means the predicate is weaker. That means the predicate allows more input values to be passed. Okay, more valid input. That means require less, more tolerance. Okay, and the best way to prove it is by saying P1 implies P2. If you can prove that P1 implies P2 always, that means P2 require less than P1. Okay, P2 is more tolerant, okay, weaker. If you, again, I think the best way to do it would be, remember the diagram I drew last time, right? Think about for each predicate you're given, think about one set for one predicate. Is the other set either a superset, like that, or is it a subset, like this? Or it could be like that. In that case, you cannot prove one way or the other for the implication. Okay, that's something very quick review from your math class previously. Okay, but we'll get there. Okay, on the other hand, we also got for the postcondition. Don't really get confused about P and Q. P and Q here, they're simply just Boolean condition, just predicates. But we just talk about Boolean condition in different contexts. In the previous slide, we talked about preconditions. So now we talk about postcondition invariance. Remember, in the very first week, we said class invariance is just like a postcondition for every feature, right? So that's why we only have to worry about postcondition for now. Invariant will just follow very straightforwardly, okay? And then we talk about one postcondition ensures more, okay? What does it really mean to ensure more? Ensure more intuitively simply means the postcondition, okay, let's say this. If Q2 ensures more than Q1, that means Q2 has higher standard than Q1. That means less values can actually satisfy Q2, right? Because it got higher standard, there should be less value that can satisfy Q2. So that means ensures more. Ensures more doesn't really mean it can allow more values. It means the opposite. It can allow less values simply because it's stricter, okay? For example, if I say I ensure more for this class, that means less people will pass because my standard will be higher. I can say ensure more if I say the cutoff for passing grade should be 70, for example. In that case, that'll be ensure more, right? I'm just making one example. It may or may not happen in the end. Okay. By the way, you have seen the marks for lab test 1, right? Now you know why last week the lab test 2 was like that. I thought it might be insulting to you, no? A little bit, yeah. Okay, anyway, if you got concerned about the lab test, please speak to me. Yeah, we still got some time before the final exam. I'll give you a little bit tips about how you can study for the exam in the final class. Okay, we'll do that. Okay. Okay, so now let's go to this particular slide over here. We're going to use the smartphone as one example to really see. Basically, we talk about substitutability when we talk about polymorphism and assignments, right? Let's say if I declare a type, let's say over here, my phone. Let me show you also a diagram here as well. I think that'll be easier. Okay, so now let's see this diagram here. So everything is under the umbrella for substitutability. Okay, substitutability Okay? What does that really mean? When you are expecting some parent class, it would be okay if you give me as a substitute some descendant objects. What we said before, the way we justify it before the reading week is to say because the descendant class objects, these descendant objects, accumulates at least many methods or features or as many codes as the parent class, so we can definitely substitute it. Okay, you support all the things that are expected by the parents. Okay, that's how we justify it before the reading week. But now we're going to do a little bit more logically. Okay, we're going to see that. We're going to see example just for you to get intuition. Okay, so now we got smartphone, the parent class, we got iPhone 6s Plus, right? So now what we have to worry about would be the parent class might have required, they might have some insure. Of course, it might be that they simply don't have any pre or post conditions, right? Maybe. Let's not worry about the extreme cases just yet. Let's talk about the more common case first. Let's say for smartphone, we have a feature called get remind. It's like a query. So we want to know for this, I'll just return a list of events. I want to get reminded about what events I have today. Okay? So get reminder will simply return a list of events. And similarly, we got this particular event also inherited to the subclass, and we're trying to redefine that, let's say. Okay? So now basically, hi. So now we got basically two preconditions. Also, we got two postconditions. So now you can think about, I'll give you the general rule again very quickly. And then we're going to get some intuition. Let's say require, let's say P here. We got Q here. Okay. So now, again, that's why I said you don't want to really memorize the rule. I can tell you what the rules is. The rule should be, if you give me P, you give me Q, the two preconditions in the parent and child classes. We want to judge to see which whether that's appropriate or not, right? You got two options over here. Either you can say P implies Q. Number two, you have Q implies P. Okay, so we talk about preconditions. Let's get a little bit of intuition. We try to connect between logic and intuition. What you have to really get intuition from is about substitutability. So now, for preconditions, okay, you got one or two to choose. Which one should be considered as appropriate design? Both of them will compile, okay? They will both compile. We are more talking about logical appropriateness. To help you answer, okay? If I say P implies Q, so that means Q over here is more tolerance, require less. Okay? On the other hand, if I say Q implies P, so that means the precondition in the subclass is stronger, which means you require more. Okay? So that means Q is more strict. How about this? Grammatically, it should be stricter. I'll just say more strict. Okay? So now, that's how you can see. So now, should one be more appropriate or number two? Okay, well, if you say two, okay, good. I'm glad you say that because that's wrong. That's good. That's fine. You know, you'd rather correct your intuition right now. Why would two be wrong? Thinking this way, I'll give you one example right away. Let's consider this. So now, let's say we got basically get reminders over here. Okay, we'll talk about smartphone over here. And also we got get reminders and we got iPhone 6s Plus, right? Two classes. Let's talk about precondition only. I can use the Greek characters here. We got alpha, we got gamma. Okay? So now first of all, let's see, in this case, we mentioned that this should be the case, right? Let's go with that root and see what might go wrong. Okay, Q implies P. So that means we got gamma implies alpha. Gamma is the battery level is larger than or equal to 0.15 over here, right? Implies the battery level larger than or equal to over here 0.1. First of all, do we agree this implication holds? Agree, right? Okay, so if you want to visualize it, let's do it. Okay, I'm just talking about logic here, right? If we try to visualize it, let's say this. Let's say this part here. So I got the battery level larger than or equal to 0.5. What's always the smallest value? 0.15, right? 15%. 16%, 17%. Now, what would be the value over here that is going to be not included? 10, 11, right, etc. Very good. Okay. So now in this case, it's going to be 10%, 11, 12, 13, and 14. Right. So that means this is okay. Right. I'm just saying a logical implication. Okay. Now let's come to another concern. What you mentioned to me was, if we got the precondition in the child class implies the precondition in the parent class, like number 2. You said to me that should be appropriate. Let's think about this following scenario. Let's say I'm having a smartphone. I just want to buy a smartphone. When you publish the interface to me about a smartphone, you tell me that I can get reminders as long as the battery level is at least 10%. Right? So now let's say I get a smartphone. Let's say it happens to be an iPhone 6s Plus. So now if my battery level is 12%, from the user's point of view or from the client's point of view, should the get reminders still be supported? You should, because according to the parent's precondition over here, 12% definitely satisfy that. However, because the precondition in the subclass requires more, it's less tolerant, it's more strict. However, this will not be satisfied by the subclass. Agree? Because 12% is not larger than or equal to 15%. Right? So what's expected by the parents from the client's point of view somehow cannot be supported by the child class. So that's not good. Right? Let me summarize what's happening here. Basically, every time, if you want, let's say given certain parent class, you just want to have some precondition for the child class. How can you be sure your design is appropriate? You want to make sure, because substitutability, you only can get a precondition that's weaker than the parent class version. Let's say in this case over here. Right? Let's say in this case, if I simply get 10% over here, if I simply give something that's stronger, that's simply wrong for the reason we just mentioned. Okay? How can we fix it, for example? Well, we should give something in the child class that will be at least tolerance as in the parent class. That's what we would like to do. Give me one example. What can be appropriate design? Yeah, for example, let's say we want to fix the parent. Let's say smartphone API doesn't change. Let's say. Okay, so now how can we fix it? Well, yeah, maybe more tolerant, right? For example, I can say, yeah, 0.1 will be fine, right? 0.5 will be the greatest value, okay? We can say larger than that. We can say larger than this, right? Would it work? Oh, actually, that 0. What I meant to write, sorry. That's what I meant to write. Good. Yeah, that will also be fine, right? Because now you're just being more tolerant at the child class level. Guys, are we okay? I think the thinking process is really important. Just in case you forget about, let's say where we came from. We basically came from this. Let's say in the exam, if we simply just tell you we got P and we got Q, we give you symbolic. We ask you what should be the rule for P and Q to be the correct design. The answer should be number 1, okay? That should be the answer rather than number 2. However, let's say you forget. What should you do? Well, just remember we did a smartphone example in the class. Just give you some value for P and Q and try both possibilities and see which one should make more sense, right? For example, you can see this is the wrong version over here, right? That doesn't work. What about this version over here? In this, let's only focus on the precondition. Okay, in this case, you can see that, okay, you can see this is larger than or equal to 10%, and this is larger than or equal to 5%. In this case, what do we have? We actually got alpha implies gamma. Agree? Okay, if you try to draw the diagram, this is what you will get. Okay, so now you got alpha, which will be 10%, you get 11%, you get 12%, you got 13%. But now what about the child class over here? is actually going to be larger than or equal to 5%, which means you're just being more tolerant. It can be 5, it can be 6, and all the way to 9%, right? Okay, that's how you can think of it. So that'll be okay, because from the smartphone API, it tells you your get reminders feature will be supported only if it's 10%, right? But now, let's say you are 10%. Are you going to survive through the iPhone 6s Plus? Of course you will, because 10% is definitely larger than or equal to 5% logically. It's just implied. That's about a precondition. Okay? We do the similar logical reasoning for postcondition. Okay? I would say from this lecture here, just get a story flow understood. The exact details, you may want to grab a piece of paper and sit down in isolation by yourself and think about it. Okay? Let's talk about the postcondition. Okay, we'll do similar exercise over here. So far, you see, we talked nothing about what's actually being checked in iPhone, but we'll talk about it in just one moment. So far, we only talk about when you are given the pre and post condition being Boolean predicates, how do you judge if the design is actually appropriate or not, right? We just talk about precondition. Okay, so for precondition, this is our mini conclusion. So this should be correct, okay? So that means the Q at the child level should be more tolerant. Let's now talk about R and S. Okay, let me use a different color. Let's say the post condition in the parent class is R, and the post condition in the child class is S. Now we got two choices again, right? Again, you got two possibilities. Should we get to say R implies S, or S implies R? Before you answer to me, let me give you a little bit hints. When I say R implies S, that somehow means, are we being stricter, or is our standard higher or lower in the child class? Okay, let me repeat my question again. I'm asking the following question. If I say R implies S, does that mean the standard for post condition in the child class being higher or lower? Well, visualize it. If R implies S, that simply means R is like this, right? And S is more like this, right? So now, if that means the post condition in the child class allows more output values to be produced, somehow in the parent class it allows fewer values to be produced. We say that the more values you can allow for the post condition, that means the less strict or lower standard it is, right? Okay, so in this case, that means the standard is lower. That means somehow, in the post condition, in this case, if we got R implies S, that means S allows more output value to pass through. Okay? It turns out, is this good or bad? Not very good. Just think about it. You know, I'm trying to give I'm expecting some functionality from the smartphone in general, but now you give me something that's lower standard. Of course, that's not good. Okay. On the other hand, if you have S implies R, okay, so that means you got S over here implies R. So somehow the child class post condition allows fewer values to be passed through. That means now you got higher standard, right? Higher standard. So it turns out this is the way to go. Okay, you can see the way you have implication between pre and post condition are simply the opposite, right? They are not the same direction. Simply because precondition is about constraining the input values. Post condition is about constraining the output value. When you are in a child class, you want to be more tolerant on the inputs, but you want to have higher standard for the output. Okay, that's how I remember it. But of course, if you really forget, that's kind of the thing you have to try to sketch yourself in the exam. You got 3 hours anyway, right? You got lots of time to think about this. Well, assuming that you're okay with other questions. Okay, guys, are we okay with this? Any questions? Yes. Yeah. You mean for precondition, right? You thought it was number 2. Yeah, as we explained, number 2 is not good.
Yeah, so if you got
Thinking this way. Yeah, thinking this way. Yeah, basically, okay, you're talking about why intuitively this is not good, right? Okay, thinking this way. I'll draw again. Basically, we're talking about Q, okay? So Q is the child class, right? I'll put a child over here, okay? Versus the P, which is from the parents, okay? And that is the parent class. Okay, so we got Q implies P. So why is that not good intuitively? Okay, you can think about as far as the dynamic type is concerned. Okay, this part here, these are all the allowable input values for calling get reminders for the child class, right? So that means there is certain value, for example, some dot over here, that actually would satisfy the parent class precondition, but now you cannot use them to call the child class anymore. That's not good. Because child class, you want to make sure it can substitute for your parent class objects, right? That's the intuition. Okay, that's for precondition, right? Good. I think drawing this circle here, circles things over here, that really helps, right? Think about what makes sense to you, right? I think everything just follows through intuitively. Okay, okay. Let's have a quick look on the. Okay, so let's see one example for this. Okay, let's now go to. I'm sorry, the diagram is a little bit messy already. I'll tell you which one you should look. Can we have a look at the postcondition? So the postcondition for the parent class is beta, okay, which is this guy here. Okay, I'm going to draw in green. What it is saying is, we want to say it's going to return a list of events, right? We want to say we're using a universal quantification. We say every event in the result, every event to be reminded should happen today. So that means from the smartphone's API point of view, we want to make sure all the reminders we get are the event that's going to happen today, just today, current events. Not for tomorrow, just today, not yesterday, just today. Okay, let's have a look at the postcondition for the child class. So now we got delta over here, and we say the following. Okay, we're just adding a little bit more. Oh, by the way, in case you want the bracket to help you, what I meant to say was this. Okay, it's a bracket here. So we're saying that in the child class, every event in the reminders is either going to happen today or tomorrow. All right? So now, first of all, before we judge to see whether they should be appropriate or not, let's figure out which implication should hold. So now let's have this. So we got green and we got blue, right? Green here, and also, oh, actually, you know what? Let me put the green here. The green here, and also we got the blue here, right? So now, first of all, let's decide. Should this be the case, or would this be the case? 1 or 2? 1? Are you sure? Why? Well, actually, 1 is correct. I can tell you, 1 is correct. But let's, well, okay, it's a very simple theorem that you did back in 1090, okay? Shall we do a little quick review? Back in 1090, P implies P or Q, right? Okay? P and Q implies P, right? And also, P and Q implies P or Q. That makes sense to you? Okay. Basically, whenever you have conjunction, you're trying to make something stronger, more restrictive. Whenever you're using disjunction, you're saying either one can happen. You make it a little bit weaker. It's easier to satisfy when you got disjunction. Conjunction, both must be satisfied, right? Good. That might be useful later when we talk about program verification, which will start after the observer pattern, okay? Maybe next Wednesday, yeah. By the way, I think since we missed one lecture because of the freezing rain or snowstorm, I forgot, whatever cause it was, maybe we should have one makeup lecture for you, so you got all the materials you get. Yes? No? How about I say yes? Yes. Good. I say yes, you got to say yes, right? Huh? I thought you said you weren't allowed. You mean oh no, not during the reading week. Oh. Not during the reading week. Somehow during the reading week, we cannot even set a deadline for the projects. Anyway, that's a standard rule. I'll think about making how about this? It's going to be half materials and half review. How about that? To encourage you to come. Okay? Good. But I'll try to choose a day. That's going to be fine. Okay, anyway, so you might need these rules a little bit later. Okay, so now if you go back here, you can see basically what you have is like this. E happens today is like a P, right? And then just another predicate using disjunction, Q. So we know that this should imply this. Okay, so now this should be the case. So now we know that according to what we are given, we know that number 1 is the case, right? Second question, is the green implies blue appropriate design or not? No. Anybody can try to explain to me why. Well, the way you explain is very easy. Since I give you a counter example, can you give me a scenario where we satisfy this design, but it appears weird? That's how you give a counter example always. Yes. So we know that basically, number 1, we know that the green implies the blue, right? Number 2, I can tell we agree that somehow, even though the implication holds, but this is not appropriate design for your postcondition. But now we want the explanation to really help you understand.
Looking at the statement,
yeah.
Both statements says E happens today, and that implies E happens today, or E happens tomorrow. If you imply that it happens today, then how does it imply that it also happens tomorrow?
You're getting somewhere. So that's why I said having a counter example will help. Can you give me a very specific? For example, maybe you can give me one extreme case for the return value for the subclass. That's not going to make sense at all, according to the original standards that's set by the parent class. Yes.
Basically, you're getting a list of all the events happening today, but then some other birthday that's another day that comes back.
You might want to say the opposite. Okay, you're getting there. Okay. How about this? I'll give you a little bit hints. Somehow we know that the blue one in the child class is more tolerant, is lower standard, in the sense that it can allow more output value to be allowed, right? It can to be accepted. So now, what if all the events from the child class over here satisfy the right-hand side only? Which means now, when I get my iPhone 6s Plus, always it gives me the reminders for tomorrow only. What's going to happen? Well, does that satisfy the postcondition for iPhone 6s Plus? It does. However, it violates the original standard that's been set by the parent class, right? Okay, let me say it again. Basically, what if, so basically well, the counter example, so this is not appropriate, right? Don't worry, everything I say over here is on the slides. I'm just trying to present in a different manner, so it's easier for you to follow. Basically, the counter example we have over here is like this. So let's say all events reminded happen tomorrow. Just tomorrow only. Which means all the E over here satisfy just the right-hand side for the disjunction. That's okay, because as long as one of them is satisfied, that's fine. However, if all the events to be reminded happen tomorrow, it is not going to satisfy this original postcondition that's been set by the parent class, because today is not tomorrow, right? Yes? Sorry, what do you mean?
Today implies tomorrow.
Happens today implies tomorrow. Wow, you're playing logic, right? Interesting. Basically, let's say, okay, you know what? Let me put a new page, otherwise everybody will be confused. Why are you making everybody's life so hard? Okay. I'll write down exactly what you would say. You know what? It's a fair question, because I might ask you in the exam. I might. Okay, it's a list. Okay, and now let's say that in the parent class, okay, I say for every E, for every E in the result, let me be precise, okay? And then I simply say E happens today. Okay, and then I have another one So this is the parent class, okay, over here. And then we got another one here. Let's say get reminders in the subclass. That's also going to return a list of events. And now for the ensure, let's say for every E, there's a member of result. By the way, you can use a cross to do it, right? If you want to implement it, right? You're saying the following, okay? Let me just put brackets over here. You're saying E happens today implies E happens tomorrow. Okay, that's basically what we are saying. Oops, well, yeah, that's fine. That's the best I can do. Okay, we got inheritance over here. Okay, so now we got the green, we got the blue, right? So now we want to argue to see whether this is appropriate or not, right? Let's be a little bit more abstract. Think about this guy here as P. Okay, you got this guy here, that's also P. And this guy here is just Q. We're basically asking the following question. For that to be appropriate design, to be appropriate, what you want to have is to say P implies Q. So this is the postcondition in the child class, right? That itself should imply the P. Is that always the case? Logically speaking, can it be the case? If I know P implies Q, does that imply P? Give me one counterexample. Well, oh no, actually, oh, I see what you mean. Good, okay. Okay, we're just trying to prove this in logic, right? So I'm just telling you this one is not good, okay? So now one way to disprove it would be if P is true and, P is false, right? P is false and Q is true. And then also P here will be also false. Would that be the case? No, right? False implies true will just give you true. True implies false, false. Okay? So it's not the case, right? That's a very good counterexample. So this is not appropriate design. Okay? How do we think about it intuitively? Actually, it's hard because, well, you know, it's, for this particular example, you say, if it happens today, that implies it happens tomorrow. Oh, maybe the same events. Maybe like a continuous events, maybe. I'll leave this to you to think about, okay? To think about intuitively why this wouldn't be appropriate design, okay? The bottom line is, any predicate, any postcondition we give to you, right? You always got to consider whether the postcondition in the subclass implies the postcondition in the parent class, for the reason that we just explained. Okay? You want to make sure the standard in the subclass is no lower. It should be at least high as the parent class, right? That's why it should allow no more values than what the parent class will allow. Okay? Guys, as I said, it's tricky, right? So you really want to at least get a big picture clear and then think about the example we talk about, right? Yes? What do you mean negation?
So if you negate the equation, you have
Which equation do you want to negate?
P implies Q implies P.
Well, actually, what? You don't change the structure of the equation over here, right? Notice one thing here. This implies over here should always be there because we want to see whether the postcondition in the child class implies the postcondition in the parent class. The structure is always there. You don't just modify the structure, right? Okay, so the exercise you really want to get familiar with is any pre or post condition we give to you in the context of inheritance, you will know how to judge them, whether that's appropriate design or not. And this is something the compiler wouldn't do for you. Okay? The compiler, it cannot prove any theorems for you. You have to prove it by yourself, by hands. Okay? Okay, any question about this? I think it's a nice example. It's a bit tricky. Okay? I just show you how you can justify logically why this particular case is not appropriate, right? But to think about it intuitively, I'll leave that to you. Think about it. Okay, that's about the examples, and then we'll do a little bit more. Okay, so here comes the confusing part. Okay, I will try to clarify the big picture first, and then before I go on. Okay, so basically we talk about all these cases. I can go over them. Okay, so all the 4 cases we talk about, the precondition versus the postcondition, everything have been talked about. Okay, let me show you one more thing. When you look at the slides, there'll be another. Oh, actually, I think we're done. Okay, that's good. One more thing to mention. So now we say that. So this particular postcondition is not appropriate, right? As we said before, it's not appropriate. What can be an appropriate version? If you look at the final version over here, right? So now if you look at the blue one, let's say the green one, beta. Again, E happens today, okay? And then you have another one, gamma here. E happens today between 9 a.m. and 5 p.m. Can you see intuitively why it would be appropriate? Right? Somehow the postcondition in the subclass, the blue one, has higher standard. Because, for example, let's say, give me one example that would be allowed in, let me say it this way. If I want to draw the circle, how would I draw it? Let's say the green one is like this, right? That's the beta. Okay? Happens today, which could be basically starting from 1 a.m., all the way to 11:59 p.m., right? For today. What about the blue one? Is it the bigger one or a smaller one? Smaller one, right? Good. So that should be something like this. Okay, that's the delta over here, right? That one will be only from 9 a.m. until 5 p.m. So that means let's choose one value over here. For example, if you choose a value over here that's outside, for example, let's say 6 p.m. Okay, how can we think about this? 6 p.m. somehow can be guaranteed by the smartphone. True. But now, in the case of this iPhone 6s Plus, now we are trying to get the standard higher. So 6 p.m. wouldn't be allowed. That's okay. Okay. Because this is nothing about input checks. Okay? It's really about what kind of a value you will accept as the output value. So it's okay to be stronger in the child class. Guys, any questions? Okay, if you're fine, okay, I would like to mention one thing before I go on to the next subtopic. Okay. So far what we talk about is like this. And then we're going to see some slides, and then hopefully I can show you a little bit iPhone Studio to show you how you can experiment the things yourself. Let's do a very quick summary. Okay. So now you got parent class, you got subclass, right? You got require. Okay. Let's say any feature. Let's say F. And also you got ensure, okay? And also you got ensure. Okay, over here, let's say we got P and Q. Oh, let's say P and R. And here we got Q and S. Okay, so let's summarize what we have done. Basically, for you to justify by your hands, logically, whether the design should be appropriate or not. Okay, you must prove the following. Okay, for the precondition, you must make sure P implies Q, right? Q is more tolerance. For the postcondition, you want to make sure S implies R. So S over here has higher standard, okay? And the Q over here is more tolerance. Okay, that's the first stage. Now, we want to get to the second stage. For the second stage is really about when you actually write something that is not considered as appropriate, what is going to happen at runtime? That's a question. I'll give you one example, okay? Let's go back to our battery level example, okay? Let me give you something that's not appropriate, okay, intentionally. Let's say for require, the battery level is larger than or equal to 10%. Over here, the battery level is larger than or equal to 15%, right? according to our rule over here, okay, we know that battery level larger than or equal to 15%, and also battery level larger than or equal to 10%. Okay, so this is not the case. So we know that it's not appropriate. Agree? So far, right? So far so good, nothing new. So now, if you put this in IFO code, it's going to compile. Now, the question is, what's going to be the runtime consequence if you put something inappropriate? IFO compiler somehow doesn't believe you too much, so they would do something for you, always. No, not, oh, actually, no, it wouldn't be precondition. Oh, it's actually a good question here. Let me give you a little bit, that's something I also make a source code for you. Okay, let's talk about it. I think this is more valuable. Can we just assume, at the moment we got feature F, okay, we also got feature F, okay, and then we got a precondition over here, and also got a precondition over here. We know that that's not appropriate, okay? So now let me ask you the following. Let's say this is a class, let's call P. Let's call parents. We'll make it very explicit. This is the class called child. Okay, so now let's run some tester over here. If I get, let's do some warm-up. If I say P is of type parents, and also let's say we got C of type child. Okay, so now let's say we already created the object. Let's not worry about rate safety. Let's say we already created. So now if I say P.F, let's say one more thing, okay? Let's assume, say P dot battery level at the moment is, let's say 11%. Oh, actually, let me just do a series of different checks for you. At the moment, let's say it's 9%. Okay? Now, if I say P dot F, what do we get? Well, this one should be easy, right? Let's say at the moment, the battery level is simply 9%. If I try to call P dot F, precondition violation, please, right? That's easy, right? So you got precondition violation. Okay, let's say later on we charge it. Let's say P dot battery level has now become, let's say 12%. What about P dot F? Would that be okay? No precondition violation, right? Very good. Okay. Now, here comes the interesting bit. Okay. This one is a warm up. Let's say we already created C, the child objects, right? Let's say C dot battery level is 16%. Okay? If I say C dot F, is it going to be fine? I did this intentionally. Somehow, 16% will satisfy both. So we haven't seen the issue just yet. Okay, let's say we do that. Okay? This is going to be fine. Let's say we use it for another hour. %. Apparently, it is going to satisfy the parent class precondition, but not the child class precondition. Do you want to take a guess? When I say C.F right now, is it going to have a precondition violation or not? Yes, no, yes, no. Okay, it seems like dynamic binding would make more sense, right? Because now since we're calling C, dynamic type is simply child, so we should call the precondition for the child class. No, nothing to do with dynamic binding. If you think about dynamic binding, in this case, you're toast. Okay, that's not good. Okay, this is going to be no precondition violation. Okay, so now dynamic binding is not relevant. in this case. This is going to be okay, because the way IFO does this is like this. Because IFO knows that for some developers, they are simply not careful enough. They might simply do the wrong design by giving a stronger precondition in the child class. In this case, they still want to protect the parent contracts. How did they do it? What they do is like this. They're going to get this one here. They're going to get this one here. What's going to be checked at the runtime over here is going to be C.battery level larger than or equal to 10%, which is inherited from the parent class, disjoint with C.battery level larger than or equal to 15%. It's actually what's being checked at the runtime. So what does that mean? Intuitively, it makes sense. Well, we know that for disjunction, as long as one side is satisfied, the whole thing should be true, right? So here's the intuition why they will put a disjunction over here. They put a disjunction over here to say, as long as the parent's precondition is satisfied, I don't care what you have for your precondition. It could be weaker, it can be stronger, but as long as the parent version is satisfied, you pass through for this particular inputs. Okay, that's the intuition. In this case, it does protect the objects because now in this case, as long as the inherited precondition is satisfied, it's okay. Even if the child precondition is stronger, even if. So this is where it is confusing. So that's why this slide here is really important. Let me summarize quickly for you. What we said before this slide here, we talked about if I just give you two preconditions, one in parent, one in the child, how do you judge on the paper whether that's appropriate or not? Okay, and that's good. But now here's another second issue here. Somebody accidentally put a stronger precondition in the child class, which is wrong logically. How does IFO runtime deal with this? They deal with this in the following sense, to say as long as the parent class precondition is satisfied, doesn't matter for the child class anymore. It just passed through. Okay? Are we okay with this? And for the postcondition, it's the same logic, the same. Yes, go ahead. Now, in this case over here, if you just review over here, when I say C.F, whereas C.battery level is simply 12%, right? 12% already satisfy the parent class precondition, so that'll be okay. Even though it violates this particular precondition, that's fine, because we're using a disjunction at the runtime. So we talk about what you have to judge on the paper versus what IFO runtime will put for you as a disjunction, right? So these are the two things. You want to be very clear, okay? Yes?
What if you change the requirement to per house?
You know what? I think that's some mistake I just made. Whenever, that's something I'm just about to say, but I just forgot. Every time if you want to do something about a precondition in the child class, you always have to say require else. You know what? It's a very good transition here. Have you thought about why it's called else? Or else, right? Remember? Or else. We say or else means the short circuit. And now, in the case of conjunction, it's going to be the opposite. It's going to be and then. Okay? So now, let's talk about the postcondition very quickly. Okay? Very quickly for you. So now, again, let's do another thing over here. Again, I'm going to say this is the parents. Okay, now we focus on the postcondition. Okay, we still got feature F. Let me just use the ensure over here. Let's say ensure, let's say X is larger than or equal to 0, for example. Okay, ensure. And also we got the child instance over here, child class. Okay, so we got inheritance over here. You know what? Let me make the error correct. Okay, that's inheritance. Okay, so now in the child class, we got F, also ensure. We know that to be appropriate design, the postcondition in the child class can be no weaker. It must be either the same or stronger, right? Let me give you something that's wrong, okay? But still compile. Let's say x larger than 5, okay? So now, over here, what we will see is, so now, what about we just say this is P, okay? We give a tag, this is Q. We know that to be appropriate, we know that Q must imply P, right? That's a rule. But it is the case that, but we have x larger than 5, larger than, I think what I meant to put over here was something weaker. Sorry about that. How about that? I think that's what I meant to put. Sorry about that. Okay, let's say we have this. To be appropriate, it must be the case that Q implies P. But if we have x larger than minus 2 implies x larger than or equal to 0, it's not the case. Okay, it's not the case. So it is not appropriate. Okay, again, that's from the previous analysis on the paper. So now we want to know, let's say somebody accidentally put these two postcondition on the IFO code. Everything compiles. Well, what's going to be checked at runtime, right? That's the issue. Okay, so now what we will have to do is, again, let me just show you something very quickly. So what you will get is, let me just go directly to the points. If we got a child type over here, let's say we also create a child class objects already, let's say, okay? If I simply say C.F, okay? So now, let's say upon termination, it could be that X is simply just an attribute for the class, right? So let's say upon termination, X is, let's say, minus 1. Upon termination, X is minus 1. Yeah, question? Huh? RS? Well, it doesn't matter. You know, they are just tag name. Yeah, sometimes they just use PQ for the predicates. Yeah, yeah. But every page should be independence. Okay. So now let's say this. So now the question for you is, if I try to somehow execute this feature call, let's say somehow at the right before we try to check the postcondition, X is simply just minus 1. Apparently, minus 1 is going to satisfy the postcondition in the child class, agree? So do you think we will be okay? Aha. The answer is we will not be okay, okay? Because we want to make sure we ensure no less than the parent will promise. Because the parents promise that X should be larger than or equal to 0, which is not the case for minus 1. So what's going to happen is, what's going to be checked, okay? What will be checked at runtime exactly? It's going to be X larger than minus 2, which comes from here, and also and X larger than or equal to 0, conjunction. Okay, so now we really talk about at the runtime, the way IFO checks your pre and post condition in the context of inheritance. For precondition, they will do disjunction. For postcondition, they will do conjunction. Okay? Disjunction in the sense that as long as the parent's condition is satisfied, you are fine. Conjunction for the ensure in the sense that if you don't satisfy the parent's postcondition, no, you got to satisfy both. Okay? Okay, so after this, okay, so that is why you will see ensure then, right? This makes sense because and then, right? Require else ensure then. So it's again, it's a language design choice by IFO. But now, it would be okay. Let's say if you actually write the exam, you forgot to require else, ensure then. Even if you say require then, ensure else, that'll be okay. No. But I think it was really more, well, I'm pretty sure somebody will do that. Don't laugh. I'm pretty sure some of you will do that. Yeah, I'm pretty sure. Hopefully from section Z, not from section M. Hopefully. Make me proud, please. So now, that's about the runtime checks. Okay, let's go over a little bit more slides and do a little bit more analysis, and then we're done for the subcontracting. Okay, let's do a little bit more. But I think I got all the intuition you need. Okay. So now we're going to talk about some interesting cases. Okay. Okay, so about the contract redeclaration rule, that's exactly what you talk about. Okay. So you're going to use require else and also ensure then. Let's go over the intuition very quickly on the slides. We have seen that already, so let's just review. Okay, so now when you have runtime assertion checks, you're gonna do, when I say original, that simply means the precondition from the parents, or else the precondition in the child class, right? You will just say or else. Okay. So that means as long as you can satisfy the original one, it's guaranteed to be satisfy everything, right? So now think about this rule over here. You can think about if you already satisfy the parent's original precondition, so that part will be true. True or anything will just be true, right? That's why we just pass, right? You can just link this to the example we just talked about in the iPad. Okay, that's good. Okay, so the precondition violation will not occur as long as you're able to satisfy the precondition from the ancestor. Okay. What about postcondition over here? Well, we say that it's going to be and then. So now think about what's going to happen. If you already violate the postcondition for the parents, the original postcondition, even though you satisfy the postcondition in the child class, what does that mean? That means you're going to have false and then new post. For conjunction, if you got false already, you got false, right? That's why. Okay, that's exactly why. So failing the original postcondition, you get false, and something will just be false. Doesn't matter what the other thing is. Okay, good. You can read it through. We already covered that. So now, let's do a little bit exercise over here. Okay, so basically the next two slides, we just want to give you a little bit exercise here to see what would be the logical equivalence to that. Okay, scenario number one, let's say the following. Let's say we got a parent class called foo. There's no precondition. Okay, just not even a require, not even that, nothing. And then we have bar over here, and then we say require else new precondition. So the require clause for the parent class is absent. The require else clause is present for the child class. I have the following question for you. When I didn't put any require in the parent class, would it be as if I put require what? Require true or require false? How about that? It's a multiple choice. Why would that be require true? Huh? Yeah, thinking this way. Okay, I'll explain to you verbally quickly. If you say it's as if we say require false in the foo, right? That means every time when you call F, you're just going to fail. You're just going to get precondition violation, right? So that means there's no way to actually satisfy the parents. In that case, let me just explain this one just for you. Okay, just you can apply the same. Okay, let me just do this one only. Okay, so we got foo over here, and then let me see this. It's called F. Okay, and then we got F. Okay, the require clause is simply missing. Okay, and then we got the bar. And then we got F over here. Let's say require else. And let's say we simply got P, for example. Oh, actually, let's say X larger than 0. Okay, so you got two options over here. Either to say this is equivalent to, I say F and then require false. That's option number one. If I say f over here, require true. So now, choice number 1 or choice number 2? Okay, can I confirm again? Which one do you think that's the case? 2? Okay, let's see. 2 is the right answer. But why is 1 problematic? Really? Let's see this. Let's see this. Let's say we got some child class objects. Let me use both. Okay. Let's say I got f of type foo, also b of type bar. If I say, okay, let's assume that we also created objects already. Okay. I can see that it can be a little bit confusing with the name. Can I just call it G? Okay, it doesn't really matter, right? Okay, just call it G, okay, instead. So now, of course, I'm gonna also say G over here. Okay. G here and G here. Okay. So now the question is, number 1, if I say f, let's say we choose 1 to be the case. Let's see why it could be problematic. If I say f dot G. Now what's going to happen here? It'll be created precondition violation, right? Okay, that's good. So this will be precondition violation. Okay, so what about the second one? The second one, let's try this. If I say G, I meant to say B over here. Okay, if I say B dot G over here, okay, so now let's say at the moment, let's say X is, let's say at the moment X is, let me leave some value over here. Let's say, what about just 5? Would this be okay? It is okay. Why is that okay though? Yeah, false or that, right? Okay. I think for this one here, let me try to see what I'm trying to say here. You can see this one is really confusing. Sometimes even myself, I can get lost. Let me try to see this. About 15 minutes. Let me just say this. You know what? I would suggest the following. Okay? So everything we have said so far is still valid. This might take another 10 or 15 minutes to finish this. I would say, can I leave just 2.1 and 2.2 for now? Okay? And then I will start from scratch on Monday quickly in about 15 minutes. Okay? Because if I go on, I might just confuse. Everything I have said so far is still valid. Okay? Nothing's wrong. Okay? But to really explain this better, let me think about a little bit more. Okay? But now, let me just skip these two. Okay? I will promise I'll come back to 2.1 and 2.2. I'll definitely come back to give you a better explanation. Okay? I'll come back here on Monday. And then I'll start from this page. Okay? But for now, let me finish a little bit more. Okay? And then we are done with this topic here. And I'll come back on Monday. So now let's switch the gear a little bit about invariance. Okay? Invariant is actually more intuitive over here. Invariant basically is really about how you can, invariant is pretty much like a postcondition for every feature. So whatever rule that applies to postcondition should also apply to invariance. Agree? Okay? So now that means if I want to add an invariance in a new class, should it be stronger invariance or should it be a weaker invariance? Let's see one example. Okay? Let's try to see this. Well, basically, first of all, we'll talk about two issues over here. Number one, if you're given two invariants, one from the parent class, the other one from the child class, how do you judge to see whether they're appropriate or not? You want to make sure the invariance in the child class is stronger. implies, right? The invariant in the parent class. The same rule as before. But now, number 2 is more interesting. Number 2 is really about when you want to evaluate the invariants. Let's say you got invariant both in the parent class and the child class. How will they be evaluated? Here it tells you the rule, just like a conjunction, like how we did it for the postcondition. Let's see how this is going to happen. Let's see one example here. Okay? Let's say we got a class called polygon. So now for the polygon class, we got invariants to say we got vertices, right? You just got an array of points. And then you say that the number of vertices should be at least 3. Okay? That one's easy. So now, you also got a rectangle over here. So now I have a question for you. In this case, do you think the invariance in rectangle is appropriate or not? By the way, everything will still compile, so we still talk about logical correctness, logical appropriateness. So how do we, what should we check logically? Do you want to check to see whether, well, let's say this. Again, let's use P and Q. Let's say this invariant over here is P, all right? P is the vertices that count larger than or equal to 3. Q is vertices that count is equal to 4. To be logically correct, should we say P implies Q or Q implies P? Q implies P, right? Okay, so is that the case? Yeah, not the other way around, right? Because when you say vertices that count larger than or equal to 3, give me one example that's going to fail the invariant over here. 5, right? Okay, that's easy. Okay, having this in mind, okay, what's going to be checked at the runtime would be, you will simply say this conjunction with this. It turns out just to be equal to 4. Okay, so now I want you to think about this. Pentagon. You know, pentagon got how many sides, right? You know that, okay? So now can pentagon be a descendants class of rectangle? Can you tell me why? Can you tell me why? Of course, you know, conceptually we know that it's not the case, right? But can you just try to tell me from the invariance accumulation point of view, what's going to be the consequence if I say pentagon inherits rectangle? What's going to happen here? It's going to violate. Yes, you want to say something? Yes. You, yeah. Yes, go ahead.
Because rectangle is the invariance must be equal to 4.
Yeah.
And then pentagon like 5, so you're checking.
Yep.
Equals 4 and equals 5.
Exactly. So we know that if you try to create a classical pentagon, the invariance would be the vertices that count is equal to 5. Now if you do the accumulation, you're going to check at the runtime vertices that count equals 4 and vertices that count equals 5. Can it be equal to 5, 4, and 5 at the same time? No, so that'll be false. Okay, that's exactly how you judge. Okay, if you look at that, it's going to be false, right? Exactly what we just said. Okay, so now I will leave. This is something I will make a conclusion next on Monday when I started with that topic quickly. Okay, we still got about 10 minutes. Okay, I will pause the logical discussion just up to now. Okay, I will revisit this for another 5 or 10 minutes on Monday. But for now, I would like to introduce you to another pattern quickly. Okay, that's basically the last design pattern we have to learn for this course, observer. But that one there is quite interesting because not only the IFO size is interesting, but also I'm going to show you how you can do it in Java. That's also interesting. Okay. So now I will just go to observer design pattern quickly. Okay. How about just take about 5 minutes and I'll let you go earlier today. A little bit too much logic today, right? So now observer design pattern. We want to see what kind of problem is being solved for this particular one. Every time you review a pattern, you want to know what kind of problem it's trying to solve. This is another kind of problem that's different from composite or visitor. Okay. Right. Let's look at the problem first. So now, for all of you took 1022, right? 1022. 1022. Do you know what 1022 is? 1022. Android, right? You guys should know how to build a mobile app, right? Kind of. Been a while. I know it's been a while. Yeah. For me, it's been a year. since I taught it. Yeah, for you guys, maybe a little bit longer. Okay. Anyway, let's say the problem we're trying to solve, let's say we got weather station. Okay. Let's say we got some weather sensor over here. Of course, a single weather station, well, there might be multiple weather stations distributed to different geographical places. Well, and also in a single weather station, there might be more than one sensor, right? Things like that. As a single one, okay, we got some sensor for maybe temperature, for the pressure, and for other measures as well, right? We'll go over that. We'll simplify the problem a little bit. But basically, imagine you're actually going to implement different apps for your mobile phone. And the mobile phone might be used from different geographical locations as well. Okay? We want to see what might be the best design to actually implement this. Okay? Let's look at the problem first to have some idea. So weather station maintains weather data. So now weather data is a keyword. Okay? So now let's say we got 3 measures we want to report. We got temperature, we got humidity, and also we got pressure. Okay? Only the 3 to make it simple. Okay? So now, let's say we got various kind of operation. So now, when you hear the word operation, don't think we're going to use visitor. Not necessarily. Okay? If you try to use visitor for this, you're going to go nowhere. Okay? So now you got weather data. So now we want to say for each app, for example, maybe for this particular app, it's going to do operation number 1. For this second app, it's going to do operation number 2. For this app here, it's going to do operation number 3. So what are the 3 operations we have? Let's say we may want to report just a current condition. Current condition would be we want to report the temperature and also humidity. That's only 2. So which means for this app, you only need temperature and humidity, right? Only these 2. Let's say for the second app, we want to forecast. We want to forecast to say, is it likely to rain? I don't know about physics too much, but it seems like if the pressure is decreasing, that means it's likely to rain. Maybe. Okay. For those of you who took physics, you can tell me more. Okay. Basically, if the pressure has been decreasing, that means it's likely to rain. So basically, for this forecast app, all you're gonna need is to maintain what's the old pressure and what's the new pressure. Compare them. If the pressure has been decreasing, then it's likely to rain. Okay. The third app is going to give you a little bit more statistics about what's the minimum, what's the maximum, what's the average temperature so far. So these are the 3 apps we would like to implement for you. Okay? Well, you want to implement that. So now we want to know what would be the best design. For this particular lecture here, I'll tell you the roadmap and then we're done. Okay? Number 1, we're going to see how you can do a very typical OO solution. Well, not quite OO. It's still like a procedure. You don't see much OO. That's the first design, and then we'll criticize it. Number 2, we're going to do the observer pattern, which you can also do very easily in Java. So either just another language you do it. But number 3, we're going to lift the observer pattern a little bit higher to something called event-driven design, for which you have to use a keyword called agents in iPhone. You haven't seen a keyword agent so far, but you didn't have to worry about it. Huh? Yeah, in the test, exactly. Agent basically like a function pointer, right? Like in C. If you program in C#, it's like a delegates. If you program in Java, in the newest version, they got something called lambda function, right? Something similar. Okay, I will stop here, and then I'll start with the subcontracting again to finish it, and then we'll come back here.